Hi students. So, எப்படி இருக்கு? So, we are continuing our revision series on chemical equilibrium. Okay. So, last week we were having the part 1 series. So, those who haven't watched the part 1 chemical equilibrium, they can go to YouTube playlist, Brainiacs Classes YouTube playlist. There you can find a playlist named BIRV, that is Brainiacs Intermediate Revision Series. There you can see all the videos that have been completed. I mean all the chapters that we have done the revision. Okay. Surely I am sure it will be very much helpful for you for your NEET exam. Okay, I hope all of you are in a little bit tension. It's a time for starting of tension because you know the notification came. Okay, and the detailed syllabus for this year's exam will come by November end or December starting. Okay, so all of you please prepare well, focus on NCERT, do almost all the questions that is available at the back side of NCERT, examples, in-text questions. Okay. So here we have selected almost all important questions from this particular part, chemical equilibrium. You know that the chapter equilibrium has two parts, chemical equilibrium and ionic equilibrium. So first we are dealing with chemical equilibrium. Okay. So equilibrium part 1 questions, you can watch it in YouTube itself in our playlist. So those who haven't subscribed Brainiacs Classes YouTube channel, please subscribe it. You will get all the latest news, everything. Okay, latest news, revision series and daily classes, everything from this particular channel. So feel free to contact us via email, or you can call us, or even you can comment on the comment box. Okay. Yep. So can we start actually? I hope all of you are watching it. Okay. If you have any doubt, feel free to put the comment on the comment box. I am here to answer you. Okay. So let's start doing this question. Okay. Yeah. It's a very easy question somehow. So we'll read the question first. Okay. What is the question all about? The question states that hydrogen, okay, how many moles are present? A moles are present. And iodine, how much moles? B moles. Okay. They reacted to give 2x moles of HI at equilibrium. So they are saying that they have reacted, A moles of hydrogen has reacted and B moles of hydrogen has reacted. And at equilibrium, when they are watching, they found that there are 2x moles of hydrogen iodide is present. Okay. Now they are asking the total number of moles that is present at equilibrium. So we know that the reaction between hydrogen and iodine, it's a reversible reaction. So first we will write down that particular reaction. Okay. So first we will write down that reaction. So hydrogen, we know, which is a gas. Okay. With reacting with iodine, okay, I2, okay, which is also a gas because I2, okay. And what you are getting, sir? What you are getting? So we can say hydrogen iodide is obtained. Okay, hydrogen iodide is obtained. So I will balance it and write that is 2HI. Okay. So I can easily say this reaction is now balanced. Correct? So what is its stoichiometric ratio? Stoichiometric ratio is 1, okay, 1, 1, 2. So 1:1:2 is the stoichiometric ratio. Okay. Now let's say at time t is equal to 0. What do you have at time t is equal to 0? So we will start with at a time t is equal to 0. Okay. So at a time t is equal to 0, you are just starting the reaction. At that point of time, you have A moles of hydrogen. Okay, A moles of hydrogen are present. Okay, and how many moles of iodine is present? Another B moles of iodine is present. B moles of iodine is present. Now tell me, when you started the reaction, whether HI is formed? No, because you have just taken A moles of hydrogen and B moles of iodine. So I can easily say there are no moles present here. So I will put here 0. Okay, this is the initial understanding. Now we know that the reaction has started at a time t is equal to 0, and after some time it will reach equilibrium. But before it reaches equilibrium, we don't know how many moles have reacted. How many moles have reacted, we don't know. So let us assume, we know that as per stoichiometry, 1 mole of hydrogen react with 1 mole of iodine to form 2 mole of hydrogen iodide. So let us assume, suppose there are x moles of hydrogen is there. Then we know that x moles of hydrogen needed x moles of iodine. Then it will produce 2x moles of hydrogen iodide. Okay. So we are assuming this x is, we don't know how much moles. So out of A moles, how many moles have reacted? I don't know. So I am assuming let it be x. Then we know that 1 mole is reacting, then 1 mole of iodine is needed. It produces 2 mole of HI. Then if x moles of hydrogen is reacting, then x moles of hydrogen needed x moles of iodine. That will produce 2x moles of hydrogen iodide. This is the concept. So let us write here an intermediate step, that is for your understanding. So let's say x moles have reacted from here. Okay, x moles have reacted. Then what it will do, it will take from B also x moles. It will take B from B also x moles it will take. Then what it will produce, it was 0 moles initially, now it has produced 2x moles of hydrogen iodide. Now let us take the condition at equilibrium. We say at a time t is equal to equilibrium time. Now equilibrium, what has happened? You itself say x moles have reacted from here. Reacted means now from A x you need to subtract. Here also from B moles x moles have reacted almost. This have reacted and it has given rise to 2x moles. So I can write here A minus x is the remaining moles that is present here. A minus x. I can say A minus x moles is remaining here. Now tell me x moles from B also reacted. So I can say B minus x is remaining here. B minus x is remaining here. These two has reacted. These x and x have reacted and it give rise to 2x moles. So that 2x moles is present at equilibrium also. So I can write here 2x moles is present. 2x moles of HI is present. Now we know the number of each element and its corresponding moles at equilibrium. Now the question asked here is the total number of moles at equilibrium. Total number of moles at equilibrium. We know the number of moles of hydrogen at equilibrium is how much. So we will write down each one for your understanding. Okay. So let's write number of moles of hydrogen, number of moles of hydrogen at equilibrium, okay, and this is equal to how much? We know that, listen, hydrogen is present here, okay, this hydrogen initially it has A moles, X moles have reacted, so at equilibrium what is remaining? A minus X moles is remaining. So I can write here A minus X. Okay, similarly, tell me what is the number of moles of iodine at equilibrium. So I can write here number of moles of I2, number of moles of I2 at equilibrium. Okay, number of moles of I2 at equilibrium, and this is equal to B minus X. Okay. You got it. Now tell me what is the number of moles of HI at equilibrium. Tell me, sir. HI initially has 0 moles, then it has increased to 2x moles. So at equilibrium it is having 2x moles is remaining. So I can write number of moles of HI, number of moles of HI, okay, at equilibrium is equal to 2x. Okay. Now we got the number of moles of all the compounds at equilibrium. So let us add it. So we can put the statement like total number of moles at equilibrium. Total number of moles at equilibrium. So if you are watching at equilibrium, how many moles are totally present for all the thing. So we can add it this. So that is A minus X plus B minus X plus 2x. Clear? Any doubt? So we can say it can be written as A plus B minus 2x plus 2x. I am adding these two. These two I am adding. Okay, minus x and minus x becomes So you can cancel this one. You can easily cancel this one. Strike it out. This to cancel. So I got the answer. What is that? How many moles are remaining at equilibrium? A plus B. So I can easily say A plus B moles are present at equilibrium. Whether do you have any options like that? Let us see. Yeah, option 3 is present. So I can say option 3 is my correct answer. Okay. So what do you feel about this question? This is how fundamentally the questions for chemical equilibrium they will ask. I hope it's clear for you. Okay. If you have any doubt, you can put it on the comment box. Okay. So first we have write down the number of moles initially, that is at a time t is equal to 0. Then we are assuming x moles might have reacted. Then how we are writing x is equal to 2x? It is based on stoichiometry. Stoichiometry says that 1 mole of hydrogen needed 1 mole of iodine to give 2 mole of hydrogen iodide. Then we are assuming, suppose x moles of hydrogen have reacted, then it needs x moles of iodine and it will produce 2x moles. Okay. So that is something like this actually. I can even elaborate it a little, like 1 mole, okay, 1 mole and it produces 2 mole. Okay. So let's write here, this is hydrogen, this is iodine and this is Hi. Okay. Now we know that 1 mole of hydrogen needed 1 mole of iodine, 1 mole of hydrogen needed 1 mole of iodine to produce 2 mole of Hi. This is the stoichiometry. Now we are assuming, I am again explaining for your understanding, suppose x mole of hydrogen is reacting. Okay, so if your x mole is reacting, suppose x mole is reacting, then we know that in order to convert 1 to x, multiply by x throughout. So you will get it. So x mole of hydrogen needed what? X mole iodine. That will produce what? 2x mole Hi. This is the simple concept with which we write. So every time you write down the stoichiometry, then you assume x, then multiply by x throughout. You will easily get it. Okay. Yeah. So I hope you understood this question. Okay. Any doubt? I hope there is no doubt here. So let's switch to the next question. Okay. So before switching to the next question, let me tell you one thing. Okay, I hope all of you are preparing well for the NEET exam. So this time also, let me say, exam will be simple. Okay, but for chemistry and physics, the question will be lot indirect. Simple in the sense you understand the concept and you can easily apply it. So there comes the problem. So most of the students, they fail to read chemistry NCERT text or physics NCERT text. So please read the NCERT text, try to understand the line by line concept, because they started asking assertion and reason. So in Brainiacs classes, that is in Coimbatore, so we have offline classes. There we are teaching them all sorts of important methods like assertion and reasoning, match the following, especially from NCERT text, all types of questions we are doing it. Okay, those students who feel like, sir, we need little more support in chemistry and physics, sir, especially chemistry and physics, you can easily approach us. That is even for single chapters you can approach us. That is what we are giving, because we want every students to prepare well for the exam. Then only they can give their best. And I told you, right, this is one important thing is our passion actually. So if you are passionate to become doctor, I surely recommend Brainiacs classes, because there you will get the best coaching and everything. Because we are actually motivated to make those students who are passionate to become doctors. It's not like somebody says, sir, now becoming doctors is the trend, so let me become a doctor. It's not like that. You have the inner self saying that, sir, I want to be a doctor, sir. I am interested in doing different, maybe different categories or different professions of doctor itself. Like me say an ortho, or let me say gynecologist. Sir, I want to do that profession, sir. That will make me happy. If you are in such intention, or if you are that passionate, I will surely recommend Brainiacs Classes. It is the best place where you will get the best coaching, and all the teachers are from Kerala. They do from the best institutes who have more than 15 years of experience. From different institutes, we are handpicking the best faculty for that particular chapter and helping our students to deal with especially chemistry and physics. Okay, because for most of the students, they say, sir, chemistry and physics is the, what you say, sir, that is preventing us from scoring good marks. So surely I will recommend Brainiacs Classes, those who are finding very much difficulty in physics and chemistry, especially with concept. Okay. In addition to that, if you are not, sir, we are far away, sir, we are not able to go there, sir. Very simple, sir. You just go to Brainiacs Classes, subscribe the channel. You will get all the important lectures of all the chapters. You can go to the playlist and watch it. You can sit at home, write down the notes and learn it. Okay. So our aim is to learn whatever, from wherever it is, try to learn it and score very good marks. Okay. So let's go to the next question. All of you, please go through the question. Okay. The question states that when ethyl alcohol and acetic acid mixed together, when ethyl alcohol and acetic acid when mixed together in equimolecular proportion. Equimolecular means what? The number of molecules are remaining the same, so the moles will also remain the same. So we can say that equal number of moles are taken initially. Okay. Equilibrium is attained when 2/3 of the acid and alcohols are consumed. So in the last question, we assumed it is X amount has reacted. Now in this particular question, they are mentioning it very clearly. At equilibrium, when equilibrium is attained, what has happened? From the initial number of moles, 2/3 of the acid and 2/3 of the alcohol are already consumed. Okay. Then they are asking what is the equilibrium constant for this particular reaction. So let us write the reaction first. So reaction is talking about ethyl alcohol. Ethyl alcohol is what, sir? C2H5OH. Okay, C2H5OH. Okay, it has reacted with the acetic acid. Acetic acid is, we know very easily, that is CH3COOH. CH3COOH. Tell me, sir, acid with alcohol. We have learned this reaction many a times. What is that? It is nothing but ester formation. Fruity smelling ester. 8th standard onwards, we are learning this reaction. Okay, when an acid react with an alcohol, you will get a fruit smelling stuff, that is our ester. So ester is what actually? CH3COO C2H5. Ester with what? Water. With water. Okay. So I hope the reaction is very much clear. Its stoichiometry is also very clear. 1:1:1:1. So let's start at time t is equal to 0. What do you have, sir? At time t is equal to 0. At time t is equal to 0, you have what? Equimolar proportion is taken. So you can initially take both alcohol and acid as even 1 mole or even 2 mole or even 3 mole, whatever it is. So let me say 1 mole. Equimolar. So here 1 mole is taken. So let me say here also 1 mole is present initially. Equimolar proportion. Okay. So there is no, since it is started, there is no product formed. So 0, and this is also 0. Okay. I hope this is clear. Now we don't want to put here X. Why? Because they already told when equilibrium is attained, 2/3 of the alcohol and acid is consumed. So we directly go to equilibrium at T is equal to equilibrium. Tell me, sir, at equilibrium what has happened? 2/3 of the acid. So 2/3 has reacted means we can put here 2/3. We can put here 2/3. So 2/3 mole has reacted. So if 2/3 mole is reacted from here also how much will react? 2/3, because 1:1 is the stoichiometric ratio. Now we know that if 1 mole of this reacted with 1 mole of this to produce 1 mole of this, then 2 by 3 mole of alcohol reacts with 2 by 3 mole of acid to form what? 2 by 3 mole of ester and 2 by 3 mole of water. Any doubt? I hope it is clear. Now please assume here all of them are in gaseous form. All of them are in gaseous form. Okay, all of them are in gaseous form. Okay, now tell me 2 by 3 has already reacted from here. So what is remaining? I can say 1 minus 2 by 3 is remaining at equilibrium for what? Alcohol. Here also 2 by 3 has reacted. So what is? So they are very clearly 2 by 3rd of alcohol and acids are consumed. Consumed means already reacted. So what is remaining here? Here also 1 minus 2 by 3 is remaining. And here 2 by 3 moles are formed. So that will remain at equilibrium. Here also 2 by 3 will be there at equilibrium. Now we got all the values, that is, the number of moles of all the compounds at equilibrium. So let us write Kc. So they are asking you to calculate the equilibrium constant. Okay. So let's write Kc. So tell me, sir, how to write Kc? Kc we learned it in initial classes. Those who doesn't know, please go to our YouTube channel and watch the first video. It's present in the playlist BIRV Brainiacs Intermediate Revision Series. So you can easily write Kc is products, concentration of the product. So that is ester CH3 COO C2H5. Okay, into concentration of water. Okay, divided by what it will come, sir? Divided by, you have C2H5 reactants, that is C2H5OH. C2H5OH into acid, concentration of acid, that is CH3COOH. Okay. Now we know these are the concentrations that is present at equilibrium. At equilibrium, what is? So for ester, how much is the amount? We can see that is 2 by 3 into concentration of water at equilibrium 2 by 3. Now tell me, sir, what is the concentration of alcohol at equilibrium? 1 minus 2 by 3. That is 3 minus 2 by 3. That is 1 by 3. And for here also it is acid also, alcohol also 1 by 3. Here also it is 1 by 3. Now we need to calculate this and get the value. So tell me, sir, what you will get it? 2 into 2, numerator 4, denominator 4 by 9 divided by what it will come? Here also 1 into 1, 1. Here 9 it will come. Okay. Now let's do it. 4 by 9 into 9 by 1. So my answer would be 4. Okay. So we can say 4 is our answer. Yes, it is present. Tell me, sir, option 2 would be the correct answer. I hope you got understand. Okay. Any doubts? So very simple question. So here also they are telling in the question, when equilibrium is attained, 2/3 of the alcohol and 2/3 of the acid is consumed. So that's why 2 by 3 has reacted. So what is remaining? 1 minus 2 by 3 and 1 minus 2 by 3. So we know that 1 mole can give rise to 1 mole of ester and water. So 2 by 3 can give rise to 2 by 3 ester, 2 by 3 moles of ester and 2 by 3 moles of water. That is how it is coming. Okay. I hope it's clear for you, very much clear for you. If you have any doubt, feel free to put on the comment box. Okay. Yeah. And here one more point I forgot to tell. Here the number of moles is 2 by 3 actually. But we know that when you are put it in the square bracket, it should be concentration. Correct? Concentration means number of moles divided by volume. So here volume is not mentioned in the question. Okay. If volume is not mentioned, what we should do? That's an important point I missed out. Very important point. So if volume is not mentioned, you need to mention like, or you need to understand like, assume the volume of the container, volume of the container in which these reactants are present. Volume of the container is equal to 1 liter. You can assume. Then you will get it correctly. Why? Because I am just explaining it one more time. So suppose if I am taking concentration of ester, okay, CH3, COO, C2H5. This is concentration of ester. So concentration, or even you can say active mass of ester. So in that case, we know active mass is defined as number of moles divided by volume. Okay, this is the definition. So number of moles, we know. What is the number of moles? We calculated. That is for ester, it is 2 by 3. Correct? It is 2 by 3 is present here. You can see here. Number of moles is 2 by 3. So I will put it here 2 by 3. 2 by 3 divided by volume. We assumed it is 1 liter. So we will get 2 by 3 itself. Okay. So that's why similarly you can do it for everything. Since volume of the container is 1 liter, so the number of moles would be equal to the same as concentration. That's why it is coming like this. Okay, I hope that doubt is cleared. Somebody put it in the comment box. Okay, yeah. Now let's go to the next question. Okay, yeah. So I hope most of the students are undergoing coaching in different institutes. Okay, your preparation might be going very well. Okay, so wherever you are feeling doubt or you are feeling uncomfortable, you can easily contact us. We will surely help you. One-to-one help is also we can provide you. So feel free to contact on the below number. Brainiacs Classes. It started some 5 years back and we delivered more than 100 plus doctors in the society, and it's like we usually considered those students who are very passionate to become doctors. We didn't consider mark as their criterion. Okay, so marks means there are students who are not at all interested but still they can score marks, but we want doctors who are very passionate to do that profession. So that's why if you have a mindset, sir, I want to be doctor somehow, sir, I don't want to do any other course. If you have that passion, please contact us. We are the right partners for you to make you very good doctors. Okay. So let's go to the next question. Yeah. So go through the question, sir. The question states that 2 moles of nitrogen and 2 moles of hydrogen are taken in a closed vessel of 5 liter capacity. You can see here 5 liter. So you need to divide the number of moles by 5. Okay, then only it will become concentration. 5 liter capacity, and suitable conditions are provided for the reaction. When the equilibrium is reached, it is found that a half mole of nitrogen is used up. So at equilibrium they have told only for nitrogen half mole is used. Okay, then they are asking you to find out the equilibrium concentration of ammonia. Okay, so you know it's all Haber's process. So you should be knowing the reaction. It's a very common reaction, I have told you. So reaction states that nitrogen, okay, we know which is a gas, nitrogen, reacted with hydrogen. So N2 plus 3H2. N2 plus 3H2. So which is a gas. It give rise to, we can say 2 moles of ammonia, because I know the balanced reaction. I am writing it as a balanced form. Okay, so you can first write the normal reaction and even balance it. Balancing is very important, because if the stoichiometry goes wrong, everything goes wrong. Please understand, if stoichiometry is wrong, it will go everywhere. In chemical equilibrium it will go wrong, ionic equilibrium the answer will go wrong, even from the basic concept of chemistry chapter the answer will go wrong. So very important, whenever you are writing the reaction, balance it. Okay, so this is the particular reaction we have. Now let us say at time t is equal to 0. At time t is equal to 0. Okay, at time t is equal to 0. So tell me, sir, what is present initially, sir? They are telling very clearly 2 moles of nitrogen and 2 moles of hydrogen are taken initially. So let's write 2 moles, okay, of nitrogen, and here also 2 moles of hydrogen are taken. So at that moment, at t is equal to 0, there is no product. I can say 0 moles are present. 0 moles are present, nothing is formed, correct? Now we know that as the time passes between time initially and before it reaches equilibrium, how many moles have reacted? It is very clearly that when equilibrium is reached, they found that half mole of nitrogen is used up. So I can easily say from this 2 mole, 0.5 mole has reacted. 0.5 mole has reacted. Now you itself tell me from the stoichiometry, if 0.5 mole of nitrogen is reacted, how much mole of hydrogen might have used up? How will you find it out? I told you one technique. First you write down the stoichiometry 1 and this is 3 and this is 2. Okay, this is for ammonia, this is for ammonia and this is for hydrogen and this is for nitrogen. This is the stoichiometric ratio. Okay. You can write it like this and then you can rub it out, no issue. Okay. Now tell me, sir, 0.5 mole is reacted from here. So let us write 0.5 here. Okay. So 0.5 means I have multiplied throughout. If I want to convert 1 to 0.5, what should I do, sir? What should I do, sir? Multiply by 0.5. So I will say multiply by 0.5 throughout. Multiply by 0.5 throughout. So 1 from 1.5 is reacted means if you want to convert 1 mole to 0.5 mole, or just assume 0.5 mole is reacted. So multiply by 0.5 throughout. So how much mole might have reacted from hydrogen? 3 into 0.5. 3 into 0.5 is 3 by 2, or I can say it is 1.5, or I can say it is 1.5 mole. And here also 0.5 multiplied by 0.5, it will become 1 mole. Correct? So now I know. Or you can just think, if 1 mole is nitrogen is used, 3 times of hydrogen is required. Here 0.5 mole is used means 0.5 into 3. 3 times of hydrogen is needed. That is what 1.5. So easiest method is 0.5 is used means multiply by 0.5 throughout on the stoichiometry. So you got the value 1.5. So I can say here 1.5 mole of hydrogen is used for this. Okay. So how much moles of ammonia is produced for that? 1 mole. So I can say 1 mole of ammonia is produced here. Okay. So I hope you got understood how I have arrived at this value. Okay. Now let us rub this. Okay. So that's why I told from stoichiometry we can calculate how much moles have reacted. Very, very important. Based on the stoichiometry only I am arriving at this particular value. Okay. Now say at time t is equal to equilibrium. At time t is equal to equilibrium. What happened? At t is equal to equilibrium. Okay. What is remaining? 0.5 mole has already reacted. So what is remaining is 2 minus 0.5. 2 minus 0.5 mole is remaining. Correct? Because 0.5 mole has already reacted. And what is remaining here, sir? 2 minus 1.5 is remaining. 2 minus 1.5 mole is remaining here. Okay? I hope it is clear. And what is remaining, sir? 1 mole has formed. So that 1 mole will be present at equilibrium. 1 mole. Now I got at equilibrium what is present. Now what you need to say, what you need to calculate, they are asking you to calculate the equilibrium concentration of ammonia, that alone. So how to find out that? So we will write here equilibrium concentration. So that is ammonia. So if you write concentration means square bracket you need to keep. So NH3 at equilibrium. So I will put it like this. This means concentration of ammonia. At what time? At equilibrium. So I will put here equilibrium. That means at equilibrium. So tell me, sir, at equilibrium how many moles are present? So we know that it is number of moles of ammonia divided by volume. Volume it has occupied. Okay. So number of moles of ammonia is how much, sir? At equilibrium 1 mole is present. So 1 divided by volume of the vessel. They have clearly mentioned it is a 5 liter capacity vessel. So I have taken here volume as 5. It's a gas, so it will occupy the whole space. So it is 1 by 5. So I got the answer, that is 1 by 5 is the equilibrium concentration mole per liter. Okay. So do you have this option? No. So what is 1 by 5? Make it decimal. That is 0.2 mole per liter. So I can say it is present, and option 3 is my correct answer. Okay. So I hope it is clear for you. Okay. So please understand the important part of this particular question is you should know the stoichiometry. Based on the stoichiometry, they say 0.5 mole is reacted means 1 mole needed 3 mole. So 0.5 needed how much? Multiply by 0.5 on both sides. So that's why I told first you write down the stoichiometry, then they are telling here 0.5 mole is used up. So based on that I know that from 1.5 is used. So multiply by 0.5 throughout. So 3 into 0.5, here 2 into 0.5. Then you will get the corresponding value. Okay. I hope you got a clear idea. So if you need a practice also, I can, there are more questions are there, you will get it. Okay. Yeah. So I hope this is clear. Now let's go to the next question. Very, very important. Why we are doing too much questions of this type is, this is where most of the students have doubt actually. Most of the students comes doubt from this type of questions. Okay. Now let's start reading the next question. Okay. So one more time I am repeating for all the students again I am telling. Okay. So please focus on NCERT. Do as many times, sir. Sir, one of the common problems that students used to tell is, sir, we are learning, sir, but we are forgetting. The problem is absent-mindedness. Okay, so whenever you are learning, try to be part of that actually. Try to visualize like that you are doing that experiment, or you are in that situation where you need to do that. What I would say is something like, you people are interested in traveling, I know. Okay, all the students are interested in traveling to different areas. Think like you are going to a new place. Let me say some places in Goa, let it be. Okay, so you don't know where is the location. So what you will do, sir? You don't know how to find that location also. So what you do? So you immediately go to Google search and you find that from Google, there is Google map is there. Then you will be continuously involved in that and finding out each right way or each left where you need to move, whether there is some hills are there, everything you will be focused to find out that particular stuff, correct? So that is like you are involving in that. So similarly, when you are learning chemistry or physics, please involve in that. It is science that we see in this nature actually. So if you are involving, the understanding will become very easy, and moreover this will become a passion for you. Every time you have a feeling like, sir, I need more problems, sir, I want to do this, sir, I want to do this. It is, you will go beyond the exams. You will do any questions that you are given. So that passion, it should come while you are learning. That will make you, surely that will help you to crack the NEET exam at the top, I will say. That will make you the best, I mean, within 10 ranks it will make you. But that passion, it should come. Otherwise, it is like you are learning some steps and you are reproducing it, and after, at the time when exam comes again, you are revising, but you don't know what you are doing. Actually, what you are calculating, you doesn't know. You don't get a feel about it. Surely it will not help you, sir. If you are becoming doctor also, my sincere advice is try to involve in that every time. Whenever you are seeing any patient, let it be your grandma, grandpa, or anybody who is not feeling well, try to talk with them, try to listen to them. What is their problem? Try to understand that and try to correlate with what you have learned. That will make you great doctors. I'm surely saying it's not like, sir, I learned only gynecology, sir, I learned only ortho, sir, I will not listen to other things. It's not like that. Try to understand, try to, try to believe that your body is a very good system and try to understand it completely. You have that curiosity, or maintain that curiosity to learn the entire things that is happening in the body. So if you have that passion, surely I am going to say you become one of the greatest doctors that India has ever seen. I will say like that. It's not like you are learning something and sitting at some hospital and writing down paracetamol and something for pain killing or anything. It's not like that. Try to learn every time. Its body is that such a miraculous thing. So every time keep learning. That will make you at the top. Okay, so let's go to the question. I am passionate about chemistry. Surely I am saying I am not like initially I was not interested. Now I could say I am very much passionate about chemistry. I want to understand how this is happening, and that passion makes you go long. So that's why in Brainiacs classes we instill students to become passionate about what you learn. That is very important. The term passion is everything, sir. If you are able to find a job that you are passionate about, your life will be, I can say, it's miraculous. It will give that much wonders for you. Okay, otherwise every time you will regret. So that's why I am telling, if you are passionate to become doctors, please try to involve in the subjects and try to learn it. Or if you are passionate about some other jobs, please follow that, sir. So if you are able to do a job that you are passionate about, you will reach the top. You don't even want to follow it up. Naturally it will take you to the top. Like our great actor Mohanlal, you know that. He is very passionate about acting, whether Mohanlal or Mammootty, whoever it is. Passionate about acting. That passion makes you to work even at that particular age. So that's why even I am saying, think about Rajini, sir. Nothing about Rajini. You might have seen the film Jailer. How much passionate about his nadai, udai, ellame you can see it actually. That is, it is giving lot of energy to other people. That's very important, sir. Whatever you do, please do it with the utmost passion. Okay. So let's continue. We have the next question in front of you. Okay. So we have the question like, 1 minute. Okay. Yeah. The question is, we have in front of you 2 moles of ammonia. Okay. Again, the same reaction. The reaction will be almost the same every time. Only the equilibrium moles may be changing. 2 moles of ammonia gas are introduced into a previously evacuated. That means it is a cleaned evacuated 1 liter vessel. So you are lucky it is a 1 liter vessel. Okay. In which it partially underwent dissociation. We know that it will not complete dissociation, will not undergo for a reversible reaction. So it underwent a partial dissociation. Okay. At a high temperature. At equilibrium, 1 mole of ammonia is remaining. Those they are saying remaining. It is not the amount that has reacted. They are not telling how much has reacted, but they are telling at equilibrium 1 mole of ammonia is remaining. Okay. So we know initial number of moles and what is at the final. So we can calculate what has reacted. Okay. So let's try to do this question. So the question here is 2 mole. The equation is 2 mole of ammonia. So let me write it little bit neat. I want everyone to follow it very clearly. You can write it down as notes as well. Okay, I will upload this PDF also in my YouTube link, so you can download it from there as well. Okay, 2 mole of ammonia give rise to N2, okay, plus 3H2. So here we started the reaction with the ammonia. Okay, so this is the reaction. Again, it's a balanced reaction. So let's start with at a time t is equal to 0. What do you have, sir? At a time t is equal to 0. At t is equal to 0. At a time t is equal to 0. 2 moles of ammonia. So we know that I can write it here 2 moles. Okay. Now we know that when you have started a reaction, there is no nitrogen or hydrogen is formed. So I can put it here 0. Okay, 0 moles, and here also 0 moles of hydrogen. Okay. Now we don't know how many moles have reacted from here. Since we don't know how many moles have reacted, we assume that is as X. So let us say X moles have reacted. Okay, let us say X moles. Okay, but here you say the stoichiometry starts with 2 moles and here 1 and here 3. Okay, so let us assume here 2x moles have reacted. Why I have taken 2x moles? Because the stoichiometry has 2 value. So let us assume 2x have reacted from here. Because based on stoichiometry, then easily I can write. Even if you write x also, you will get the answer. Then what you need to do? If x moles have reacted, then here it would be, then I can write here it would be what? Here 2 is forming, here 1. So it would be x by 2. Here how much? Here 2 is forming and here 3 is there. So that difficulty will come into picture to write down that. So that's why I am always preferring to write as per stoichiometry. That will make your life very easy. So let us assume 2x moles have reacted. So tell me, sir, if 2x is reacted, how much might have formed here? If 2 is reacted, 1 is formed here. So 2x means how much might have formed here? X, 1 into x. And 2x is reacted here, 2 moles are reacted, here 3 will be formed. So 2x means how many would be formed here? 3x. So that is why always we will put the x according to stoichiometry. That will make your life very easy. Okay. Okay. I hope it is clear for you. Now 2x moles have reacted. That means x moles of nitrogen is formed and 3x moles of hydrogen is formed. So that's why I am telling just to take the x and multiply by the stoichiometry and put it here. If you don't understand the concept much, what you do, take the x, multiply by the stoichiometry coefficient. Here it is 2. Take the x everywhere. Then take the stoichiometry coefficient, that is 2. Put here 2, here 1, here 3. Easily you can write this step. That is a shortcut. Okay. Suppose here the stoichiometry was 1, 3, 5. Let us assume. Then take the x, 1x, then this become 3x, this become 5x. You can put it here. Okay. So very simple. Take the x, multiply by the stoichiometric value and put it in the second step. That means this much amount of moles have reacted. This many moles have decomposed, that have given you x moles of nitrogen and 3x moles of hydrogen. Now tell me, sir, at equilibrium, what is remaining, sir? We know that 2 minus 2x would be the remaining one, because 2x moles have already reacted. So I can say from 2x have reacted. So 2 minus 2x moles is remaining. Okay, here how much x moles have formed? X moles have formed. Here how much? 3x moles have formed. 3x moles. Now in the question they clearly say at equilibrium 1 mole of ammonia remains. At equilibrium 1 mole of ammonia remains. That means we can easily say equilibrium, the number of moles what we have got is 2 minus 2x. They are saying this 2 minus 2x will be equal to what? 1, because this whole value is equal to 1 is already mentioned in the question. So we can say that it is given that at equilibrium the number of moles of ammonia is equal to 1. It is given. It's already given that at equilibrium 1 mole of ammonia remain. So we know that from calculation we understood that is 2 minus 2x. Okay. So we can say 2 minus 2x is equal to 1. So what is the advantage of this? You can calculate x value. So 2x I am taking in the right side and 1 I am taking to the left side. So 2 minus 1 is equal to, how much it will become, sir? 2 minus 1 is equal to 2x. So I can write it as 2x is equal to 1 or x is equal to 1 by 2. I got the x value, sir. Now I can easily calculate the number of moles of nitrogen and hydrogen at equilibrium. Okay, so we will write it down one by one. So what is the number of moles of ammonia at equilibrium? It's already given in the question. Number of moles of ammonia, it is 1. But please check out, if you are writing the concentration, check out the volume. The volume, it is mentioned clearly, it is a 1 liter vessel. So you don't need to worry about it. Number of moles would be equal to concentration. So I will write it here 1. Okay. And next what you need to do for nitrogen, what is the concentration, sir? We know that it is x. So x we already know it is 1 by 2. So I can put it here 1 by 2. Next one, hydrogen, sir, how much? Concentration of hydrogen, how much it is coming? It is 3x. So that is 3 into 1 by 2, that is 3 by 2. Okay, now I got the equilibrium concentration of everything. So what you are need to calculate? The Kc value. So we can write down the Kc. How will you find out Kc, sir? Kc is equal to concentration of the product. Product is what? N2 and 3H2. So we can write concentration of N2 into concentration of H2 the whole cube based on law of mass action divided by 2 mole of ammonia. So NH3 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 the whole square. Okay, because it is 2NH3, correct? Now let's substitute the value. What is nitrogen concentration? 1 by 2, okay, into what is the concentration of hydrogen? 3 by 2. So 3 by 2 the whole cube, I can substitute here 3 by 2 the whole cube, divided by concentration of ammonia, that is 1. I can put it here 1 the whole square. So do it. So what value you would get it, sir? Complete it. And 1 by 2 into 3 by 2 into 3 by 2 into 3 by 2. So 3 into 3 9, 9 into 3 27. Okay, divided by 2 into 2 4, 4 into 2 8, 8 into 2 16. So 27 by 16. So 27 by 16 would be my correct answer. So is that present at option? So I can say my answer is 27 by 16 would be the Kc value. Okay, so I hope you got understood the answer. So very clear. So the fundamental concept is finding out the number of moles that have reacted. This is purely based on stoichiometry. Then at equilibrium, what would be the value? The number of moles initially present minus the number of moles that have reacted. They have clearly given this particular value, 2 minus 2x is 1. They clearly mentioned in the question at equilibrium 1 mole of ammonia is remaining. So that's how 2 minus 2x is equal to 1. Then you calculate the x value, substitute for other x values to get the equilibrium moles. And since volume is 1 liter, we are getting the concentration would be equal to number of moles. Okay. I hope it is clear for you. Let's start with the next question for you. Okay. All of you please go through the question, and if you have any doubt, feel free to put it on the comment box. Okay. Don't feel any bad about it. Very, very important. You need to put it on the comment box if you have any doubt. And if you have liked our channel, please subscribe it. So you will get each chapter. You will get organic also. We are starting very soon. So you will get revision questions. Just to do it, that's sufficient. You will get very good marks for NEET exam. Okay. The question states that 4 moles of PCl5 dissociated at 760 Kelvin in a 2 liter flask. Very, very important. Here the concentration would not be equal to number of moles. Why? Because you need to divide by volume 2 liter. Okay. It is according to the equation PCl5 giving PCl3 and Cl2 at the equilibrium. 0.8 mole of chlorine is present in the flask. So they are saying at the equilibrium 0.8 mole chlorine was present in the flask. The equilibrium constant is. Okay. So let's write down the question first. So you have PCl5. Okay. Which is a gas. It undergoes decomposition. Okay, forming PCl3, which is a gas, plus chlorine, which is a gas. Okay, now this is the reaction. Now tell me, sir, this is a balanced reaction. Okay, let's start with at a time t is equal to 0. So at a time t is equal to 0, what is the condition, sir? Okay, at a time t is equal to 0, 4 moles are present. So let's write here 4. Okay, 4 moles. Here nothing is present initially. So you can put here 0. Okay, now what they are telling? 0.8 moles of chlorine was present in the flask at equilibrium. At equilibrium, 0.8 moles of chlorine was present. So at equilibrium condition, they are telling. So we don't know how many has reacted here. So let us assume here x. Then multiply with the stoichiometric coefficient. Here it is 1. So you can multiply by 1. It becomes 1 into x, 1x. Okay. So it's very easy. So you have assumed here x moles have reacted. Okay. So here also stoichiometric coefficient is 1. So 1 into x, here also x will come. 1 into x, here also x will come. Okay. All are moles. Now at equilibrium, we will write at equilibrium. Tell me, sir, at equilibrium what is remaining, sir? X moles have already reacted. So what is remaining is 4 minus X. 4 minus X moles is remaining. Okay. Here X moles of PCl3 is formed. So that X will be present at equilibrium. So X moles. Here also X moles of chlorine. Okay, now in the question, so it is given that I can write, it is given in the question that it is given in the question that at equilibrium, how many moles of chlorine is present? 0.8 mole of chlorine is present. 0.8 mole chlorine is present. So this is mentioned in the question. So we know that how many moles of chlorine is formed at equilibrium as per our calculation X mole. So I can easily say X is equal to what? 0.8. 0.8 mole. Okay. So this is how you can easily get the X value directly mentioned. If it is 2X, what you need to do? 2X is equal to 0.8. If it is 3 minus 2X or something like that, then that value minus 2X is equal to 0.8. Here it is X. So we put it as X is equal to 0.8. Now you can calculate the number of moles of PCl5 based on this. Tell me, sir, what is the number of moles of PCl5? Number of moles of PCl5. Number of moles of PCl5 is equal to what? 4 minus X. 4 minus X. That is 4 minus 0.8. How much it would be, sir? 3.2 moles. Similarly, do it for number of moles of PCl3. For chlorine, we already know. For PCl3, it is X. So it is again 0.8. And chlorine, it's already mentioned in the question. So number of moles of chlorine would be how much? That is also equal to X, and that is equal to 0.8. Okay. Now we know the number of moles. So now we will calculate what is the volume of the vessel. It's a 2-liter flask. That's why I put it. We need to calculate the concentration separately. So the volume of the flask is 2 liter. It is mentioned in the question. So let's calculate the concentration of PCl5 first. So what is the concentration of PCl5, sir? Number of moles divided by volume. Number of moles divided by volume. So that is 3.2 divided by 2 liter. Okay. Everybody will forget dividing with the volume. So volume is 1 liter means it's very easy. Concentration would be equal to number of moles. But if the volume is any other value, please don't forget the B value. So concentration of PCl3, sir, tell me sir, what it is. PCl3, number of moles divided by volume. So number of moles is nothing but 0.8 divided by 2. Okay. Similarly, what is the concentration of chlorine, sir? Concentration of Cl2. Again, that is also number of moles divided by volume. Okay. So what it would be? 0.8 divided by 2. Okay. I hope this much is clear for you. Now you can easily write equilibrium constant K. Tell me, sir, how to calculate? We will take a new color. Okay, K, that color is already present. We'll take gray. Okay, we'll calculate Kc. So Kc is equal to what, sir? Kc, from the equation we can write product by reactant. Product is PCl3 and chlorine. So we write it like PCl3. Concentration of PCl3. Coefficient is 1. So this would be 1. Chlorine, concentration of chlorine, Cl2. That is also gas. So we need to include in the equation raised to 1 divided by PCl5. PCl5. Okay, its coefficient is also 1. So it's very easy. You can put it here 1. Then now you can substitute the value. PCl5, you know, 0.8 by 2. So you will put it here 0.8 by 2 into 0.8 by 2 divided by, how much it will come, sir? 3.2 divided by 2. So let's calculate this. 0.8 by 2 is 0.4. So 0.4 into 0.4. 0.4 into 0.4. Here 3.2 by 2 is 1.6. So you can multiply by 100 on both sides. So this will become 100. You will take 10, you multiply by 100 on numerator, it would become 16. Denominator also you can multiply by 100, it would become 160. So that is nothing but 1 by 10, or I can say that is 10 power minus 1. Okay. So from the options, 10 power minus 1, 1 into 10 power minus 1, how beautifully they have written down the options. So option 1 should be the correct answer. Okay. So I hope it is clear for you. It's a very easy question. Only thing, some calculation is there since volume is different. So you need to do that. Okay. Now let's go to the next question. So we will make it little fast. Okay. If you have any doubts still, feel free to put it on the comment box. So it's very easy, then we can do it. Okay. The question here is very simple. When 3 mole of A and 1 mole of B are mixed in a 1 liter vessel. Okay. How many are given? 3 mole of A initially and 1 mole of B are given. And the following reaction has happened. Some hypothetical reaction. The equilibrium mixture, if you are taking, they are telling it contains 0.5 mole of C. So they are saying at equilibrium 0.5 mole of C is present. They are asking you what is the value of equilibrium constant for this particular reaction. So let us write down the reaction. First, let's write down the reaction. So the reaction is A, which is a gas mentioned in the question, reacted with B, which is also a gas, to give rise to what? Tell me, sir. It will give rise to what? It will give rise to 2 mole of C. Okay, it give rise to 2 mole of C, which is also a gas. So our stoichiometry is what, sir? 1:1:2 is our stoichiometry. Now let's say at a time t is equal to 0. Time t is equal to 0. Let's say at a time t is equal to 0. What is present, sir? When you are starting the reaction, 3 mole of A is present. So let's write here 3 mole. And how many mole of B is present, sir? 1 mole of B is present. So let's write here 1 mole. Now what is the number of moles of C? Nothing is formed, so I can put here 0. Okay, 0. Now we know that as the time passes, something might have reacted. So we don't know what it is. So we say X. So take the X here, and X should be multiplied by this stoichiometric coefficient value. So X into 1, X. So I can write it here, X moles of this have reacted. Okay, X moles from A, X moles have reacted. So here also take X and multiply by the stoichiometric coefficient. So X moles of B have used for that reaction. Okay, so how much amount of C would be formed? Take X and multiply by the stoichiometric coefficient 2. So you would get 2X moles. 2X moles of C might have formed. Okay. Now tell me, sir, at equilibrium. At equilibrium, what is present? At equilibrium. So at equilibrium, we know that X mole have already reacted and or consumed. So what is remaining? 3 was initial value. So X have already removed or consumed. So remaining is 3 minus X. 3 minus X mole. And what is remaining for B? 1 mole was present. X is already reacted. So it would be what? 1 minus X. 1 minus X mole is remaining here. So how much is formed here? 2X moles are formed here. So 2X mole. So 2X mole of C is formed. So we know the number of moles here. Now please assume again it is a 1 liter vessel. So you are lucky. 1 liter vessel. So now concentration and number of mole would remain the same. Okay. Now they have given in the question, they are now, it is mentioned, we can write it that it is given in the question that it is given in the question that it is a clue for calculating the x value. It is given in the question that at equilibrium, or if you are taking the equilibrium mixture, how many moles of C is formed? If given at equilibrium 0.5 moles of C is present. So this is from the question. So that means what? Actually we have got 2x moles of C is present at equilibrium. So we can equate that. So we can say 2x number of moles of chlorine, C at equilibrium is equal to 2x, and this is equal to what? 0.5. Okay, so from this x is equal to what? X is equal to 0.5 divided by 2, or we can say half divided by 2, that is 1/4. So I got the value of x. Now let us calculate similarly the number of the concentration of A, or A value, number of moles of A. Okay, so the number of moles of A would be 3 minus x at equilibrium. So that is equal to 3 minus 1/4. Okay, that is 3 minus 1/4. You can either do it as fraction or even decimal. 1/4 is 0.25. From that 3 is subtracting, means you will get 2.75. Okay, like that you can do. Now similarly number of moles of B, how much it is, sir? 1 minus x. So 1 minus 1/4. So that is nothing but 0.75. We already know the number of moles of C. It's given in the question directly, 0.5. So I can write it here, 0.5. Okay, it's directly mentioned. Or what you do, 2x, 2 into x is 1/4. Again you will get 0.5. Or it is mentioned in the question, sir. Now we know that here number of moles of A is equal to constant. Why? Do we need to find out separately the concentration? No. Why I am telling that? Because volume is 1 liter. So if you want to do it, you do it like this. A is equal to, concentration of A is equal to number of moles divided by volume. So number of moles is 2.75 divided by volume is how much? 1 liter. It is mentioned. Same value. Similarly, number of moles of B is how much, sir? Number of moles of B, N by V. Okay, that is 0.75 by 1. Okay, and similarly the number of concentration of C, or active mass of C, is how much? N by V, that is 0.5 by 1. Now I got all the concentrations. Now what you need to do, sir? Find out the Kc equation. Okay, so what is the Kc equation? From the equation you need to find it out. Kc is equal to, products is C and its coefficient is 2. So we can write it like concentration of C the whole square divided by concentration of A and its coefficient is 1. So we can put it like 1 into concentration of B and its coefficient is also 1. Okay, now substitute the value. C value you are getting it as how much, sir? 0.5. So we will put it as 1/2 the whole square divided by concentration of A is 2.75 into concentration of B is how much? It is 0.75. Okay, so you can say you have to calculate this. So how to do that? 1/4, it's 1/2 into 1/2, that is 1/4, that is 0.25. Okay, into 2.75 into 0.75. So you can easily say 25 and 75 into 3. You will get this. So cancel this. You will get 3 here. So next is 2.75 into 3. So 2.75 into 3 means how much it would become. If it is 3 itself, let us assume this value is 3. 3 into 3, 9. So 1 by 9. 1 by 9 is almost equal to 1 by 10, that is 0.1. Correct? So it would be little more than 0.1. So I can say somewhere the answer would be 0.12. How I have done it? Approximation, please listen. Very, very important for saving time. This is 1 by 2.75. I am writing it. Please listen down. 1 by 2.75 into 3. This 2.75 we can even approximate it as 2.8 into 3. Okay. So 2.8 into 3 means I am taking this 2.8 as, let us say, 3. So how much it is? 1 by 9. So we know that if it is 10, what you will get? 0.1. Correct? But this is not 1 by 10. This is something less than 10. Let it be 1 by 8. So what will happen? We know that it was 0.1 here. So it should increase a little when it is 1 by 8. So let us, I am taking 0.12. Okay, or it is something like 0.13, 14 or 15 or 16, whatever it is. Let's look at the options. You can see only one value that is present below 1. Okay, from that itself I can get the answer. You don't need to calculate that and waste the time. So let me say, so option 1 is the correct answer. But if your options are like 0.12, 0.15, 0.18, then you need to do the calculation correctly. That's why whenever you read the question, first also go through the options and see whether all the options are very distant or not. Here all the options are very distant. 0.12 and one is 6 and one is 1.5 and other is 3. Very, very distant. So you can do some approximations and get the answer very fast. Okay, I hope it is clear for you. Now let's go with the next question. All of you please go through it. At 700 Kelvin, the equilibrium constant Kp for the reaction is given as 1.8 into 10 power minus 3 atmosphere. The value of Kc for the above reaction at the same temperature in mole per liter would be. Okay, so they are asking you to find out the Kc value. Okay, but they have given the Kp value. So we have already learned in our first concept there is a relation between Kp and Kc. So first we write down the reaction. So 2SO3 giving rise to, listen, 2SO3 giving rise to what, sir? 2SO2 and O2. We know that both are gases, so don't worry, everywhere you can put G. Why I am putting G? Then only it will come in Kp or Kc equation. If it is a solid or liquid, its density value is constant. It will be always, its concentration is 1. Please remember that. Okay, so tell me, sir, what is Kp? Kp value is mentioned in the question. Kp, what is Kp? Kp is 1.8 into 10 power minus 3 atmosphere. This is mentioned in the question and they are asking you to find out Kc value. Okay, this is what you need to find out, and we know that how it is related. Kp is equal to, we have done the derivation also in our first one, so you can watch that video to get the more understanding. So Kp is equal to Kc into RT raised to delta Ng. Very, very important, Ng should be there, because delta Ng is what? Number of moles of gaseous product minus number of moles of gaseous reactant. Correct? So it is given in the question that Kp is 1.8 into 10 power minus 3. We need to find out Kc. Okay, and we need to put R value. R, we need to take it as, since it is mole per liter, R value would be, you need to learn this, 0.082. And what is the temperature mentioned in the question? Temperature 700 Kelvin. So I can put it here 700. And delta Ng, how would you calculate, sir? Delta Ng. So delta Ng is what? Number of moles of gaseous product. So both of them are gaseous in nature. So both of them are gaseous in nature. Here 2, here 1. So 2 plus 1, I can say 3. Okay. So 3 moles of products are there minus number of moles of gaseous reactant. Here 2. It's a gaseous stuff. So minus 2. So that value will give you 1. Okay, so I can give it here raised to 1. Okay, now tell me, sir, what is Kc from this one? Kc is what? So Kc is equal to 1.8 into 10 power minus 3 divided by 0.082 into 700. How can you calculate this, sir? 1.8, we will keep it like that. Okay, we will multiply the 100 with this one. So this would become 8.2 into 7 into 10 power minus 3. Okay, so before I am doing the full calculation, let me look at the options. Options look little far away from each other. So we can do little bit of approximations. It's fine. Okay, so I am increasing this numerator value to 2. 1.8 I am incrementing. Okay, and this I am decrementing to 8. Okay, into 7 into 10 power minus 3. So this would become what, sir? 4. So I can say 1 by 28. Okay, 1 by 28. So maybe I can increase this a little more to make it a perfect figure. 1 by 30 into 10 power minus 3. See here, 1 by 30 into 10 power minus 3. All these are approximations. So 1 by 3 I already know. 1 by 3 I already know. This 10 I am taking forward means it would become 10 power minus 4. So 1 by 3 is how much, sir? 0.3. So 0.3 into 10 power minus 4 it would become. So I multiply by 10 on both sides. This will become 3. Okay, we will see there 3. Multiplying by 10 on both sides, it will become 3 into 10 power minus 4 by 10. So the answer would be 3 into 10 power minus 5 approximately. Do I need to explain it one more time? You can rewatch the video one more time, then you can see it how I arrived at this particular answer. So I approximated it and arrived at an answer 3 into 10 power minus 5. Okay, so let's put it that 3 into 10 power minus 5. So let's see the options. So yes, somewhere near to that we have an answer. So option 2 should be the correct answer. Okay. Do I need to explain it one more time for those students who didn't understand? Let me say, you have 1.8 with you and here 8.2 into 7 is present. Here 10 power minus 3 is present. So first I will make the decimal to normal value. 1.8 nearby value I can take it is 2. Okay, here 8.2 nearby value I can take it as 8. So 8 into 7 into 10 power minus 3. So you do the calculation, it would become 1 by 4. So 7 into 4, 28. So 1 by 28 into 10 power minus 3. So 1 by 28 is not a perfect value. So I will take it as 1 by 30 into 10 power minus 3. So again you can do it as 1 by 30 is 1 by 3 and 10 I am taking in the numerator. So 10 power minus 4. Now I am multiplying with the 10 on both sides. So this will become what, sir? 10 by 3 into 10 power minus 4. So this 10 also I am taking in the numerator. So what it would become? 10 power minus 5. So I can write it now this as 10 power minus 5. Now this, if you are calculating, this would become approximately 3.3 into 10 power minus 5. So that I am taking it as 3 into 10 power minus 5. Understood? So usually if I am not well versed with multiplication, I will do the approximation. One thing you can do it in approximation is, if you are increasing the numerator, try to increase the denominator also. Okay. And if you are trying to decrease the numerator, try to decrease the denominator as well. Here, but I am increasing the numerator and slightly decreasing the denominator. Since it is a slight value, I am doing it. Even you can increase this 8.2 to 8.5 also. Then also you will get a most perfect answer. Okay. I hope it is clear for you. Okay. Now let's arrive at the next question. Very, very important. It is based on Lee-Chatelain's principle. And this is very, very much important for you. Okay. Yeah. We will try to do that. Okay, it's very good question. Yeah, the question here is, read the question all of you. Yeah, the question given here is 2x, okay, which is a gas, given the reaction 2x plus y, which is a gas, giving rise to, okay, this is giving rise to what, sir? Z, which is also a gas, plus 80 kilocalorie. Okay. So from this, many things I can assume actually. Whenever a reaction like this is given, first thing you should learn about this particular reaction is, whenever a reaction is given and let us assume another reaction, I am giving you an example, and they are putting here x kilocalorie with a positive value, always I am referring with the positive value, we are going to say positive value on the product side. Positive value on the product side means this much amount of heat is liberated. I can easily say this is an exothermic reaction in the forward direction. Exothermic in forward direction. So it is exothermic in forward direction means what, sir? It would be endothermic. You need to learn like this. Endothermic in backward direction. Okay. Now suppose they are giving you a reaction A plus X kilocalorie gives you B plus C, given like this. Now you can see here positive value of X is given in the reactant side. Then I can say this is endothermic in the forward direction. Why? What is that is meaning? This positive value means heat is flowing into the system, and this heat is used by A to form B and C. That is the meaning. Here positive value in the product side means this much amount of heat is liberated, moving out of the system, liberated. So this side is exothermic. Okay, so this is endothermic in forward direction. Okay, that means what? In the reverse direction it would be exothermic. Exothermic in backward direction. Okay, this idea if you are getting, sometimes even they can give like A plus B minus X. If it is minus, what I am telling is please convert it into positive and then analyze, or don't by heart both. Always make the heat value positive and see whether it is on the product side or on the reactant side. If the positive value comes in the reactant side, it is endothermic in the forward direction and exothermic in the backward direction. If the positive heat value comes in the product side, it is exothermic in the forward direction and endothermic in the backward direction. I hope you got this idea. Okay, clear for you? Okay, I am rubbing this. You can note down this in your note if you are required. You can just rewind the video and write it down. Okay. So here from this you tell me, sir, it is having 80 kilocalorie. So that means I can easily say this reaction is exothermic in forward direction. It is exothermic in the forward direction and endothermic in the backward direction. Clear? I hope this idea you got it. Okay, this is very important, getting this particular idea. Okay. Okay. Now let's try to understand it a little bit. Okay. So which combination of pressure and temperature gives the highest yield of Z at equilibrium? So whenever you are doing Le Chatelier's principle, always do the question like action and reaction. So here action should be what? They are asking you what action you need to give. Action means in terms of pressure and temperature. To get a reaction, what is the reaction you need? High yield of Z. Okay, so I will write it like that. We need a reaction or we need an output. Reaction. It is almost like Newton's third law, Le Chatelier's principle. Reaction is we need high yield of Z. High yield of Z is required. High yield of Z. needed. So what does that mean? That means the concentration of Z or the amount of Z should be very high. It should be very high. So for this, what should be the input you need to give? So the input can be, they are asking in terms of pressure and temperature. Okay, first we will do in terms of pressure, then I will explain you the temperature concept. So while doing pressure, it's very important, try to find out the number of moles associated with this. Okay, try to find out the number of moles associated with this first. Okay, yeah. So what is the number of moles? 1 minute students, just a minute, there is some problem I face here. Don't worry, we will do it. Okay, we will take the application. Okay, we will try to find out. Yeah, 1 minute, we will do it, sir. So we will try to open with something else. Good notes sometimes will create issues. Okay, we will cancel this and we will take this one. Okay, yep. So tell me, sir, what do you need to do? First, calculate the number of moles of the reactants side. Reactant side, if you are checking, you can see 2 plus 1. So usually here 3 moles are present. And at the product side, you can see only 1 mole of Z, coefficient is 1. So I can say 1 mole is present. So tell me, sir, as per Le Chatelier's principle, you want high yield of Z here. High yield of Z here. So that means the reaction should shift in what direction? In the forward direction. So in the forward direction, if you are shifting, you can see it is shifting to lesser number of moles. Lesser number of moles it is shifting. So lesser number of moles means what it is doing, this lesser number of moles will collide with the vessel and the pressure is decreasing. Please listen to what I say. Pressure is decreasing. So what you need to give it as input. If you are applying high pressure as per Le Chatelier's principle, it will the reaction would be less pressure. Correct? Here what we need is less pressure. Why? If it is less pressure, it will shift in the forward direction and the concentration of Z would increase. So what you need to give? High pressure. So the input should be high pressure. From the options, you can see both two options have high pressure here. 1000 atmosphere, 1000 atmosphere. So I can say the input you need to provide here is high pressure. I'm explaining it one more time. If you apply high pressure, what would be the Le Chatelier's concept? What the reaction would be? As per Le Chatelier's principle, the reaction shift in such a direction so as to decrease the pressure. So here, in order to decrease the pressure, the reaction should shift in the forward direction. Why? Because in the forward direction, number of moles are very less. Because if number of moles are very less, it will very less number of moles will collide with the container and the pressure will go down. But if it shift in the backward direction, 3 moles are generated every time. That means more number of moles will collide with the container and pressure would increase. Correct? We want high concentration of Z. If Z needs to be increased, what it should do? It should shift in the what direction? Forward direction. If forward direction should happen, forward direction is shifting means pressure will come down. That is the reaction. Correct? Pressure will come down. So what is the input we should give? High pressure. So automatically pressure will come down. In order to make the pressure come down, it will shift in the forward direction and more amount of Z would be produced. That is how I identified we need to give an input that is high pressure. Okay, next we will come to that is what is temperature. So see here, if you want to move forward, if you want to shift in the forward direction, it is exothermic. That means heat is liberated. Heat is liberated or heat is going down or heat is heat in the system is increased. Correct? You have the system. So in the system, if heat is liberated in that particular system, heat is increasing because heat is liberated actually. Now what you should do? What you should do in order to make it move in the forward direction? You should consume. Okay. 1 minute. Okay. You should decrease the temperature. So what is the input you should give? Input should be low temperature. Why? Why I am arriving at a low temperature? Because if you are applying a low temperature to a particular system, what system will try to do? If you are decreasing the heat, what the system will try to do? Low temperature means decreasing the heat. If you are decreasing the heat, what the system will try to do? It will try to increase the heat. How the system can increase the heat? You can assume like the whole things are happening in this particular vessel. Okay, in this vessel you have this reaction is happening. So initially I have measured the temperature. Let it be 100 degree. Okay, let it be 100 degree. If you want to increase this particular temperature or increase the heat, what you should do? You should apply a low temperature. Then what it will do? You are decreasing the temperature to 90 degree. Now as per Le Chatelier's principle, what it will try to do? It will try to increase the temperature so as to get back the older value or try to get the older equilibrium constant. So in order to increase the heat, in order to increase the temperature to the 100 degree, it needs to shift in the forward direction. That is what we required to get the higher concentration of Z. So what you need to apply? Low temperature. So in this particular question, they are giving the output and asking you what is the input. So that's why from this option 3 would be the correct answer. Why? If you apply a high pressure and a low temperature, the system will try to decrease the pressure by shifting in the forward direction, and a low temperature means it will try to increase the temperature by shifting in the forward direction, so that more amount of heat is liberated. Liberated means in the system heat will come and the temperature will increase. So that's why apply 100 degrees Celsius. Okay. So I hope you got a thorough understanding with this particular chapter. We try to do almost every type of questions. Okay. So we have some more questions left here. The solution is also given. You can go through it. Okay. The solution is also provided. So again I am telling, we are part of Brainiacs Classes. So we are giving one of the best coaching in Coimbatore. We are located only at Coimbatore, and we are selecting those students who are passionate to become doctors and giving them the good coaching at a very affordable fee. Okay, so thank you for watching this video continuously. So the next week we will come with the next part of this chapter, that is ionic equilibrium, at 4 p.m. every Sunday. Every Sunday 4 p.m. you can see one chapter we are revising, and you can also download this PDF. While downloading this PDF, I will answer that also and will upload there, so you can download it. Okay, thank you. Thank you. So do it well, prepare well for the NEET exam. Okay. Yeah.